In this video, we're going to look at the normal cumulative distribution function, or NormalCDF for short. What that tells us is that we're going to look for what percentage of numbers in a list fall below a certain point, or above a certain point, if that happens to be what I'm looking for. So I'm going to put my data into the list just like I normally would. I'm going to use the presidents and their wives for this data, and I'm going to do one variable stats. First, I'm going to use L1, which is the list of all the presidents and the ages of their death. If I were using a different list, I would do L2 for the president's wives, for example. I'm going to go down and calculate and find the mean, the standard deviation, etc. And I'm assuming that the presidents are a good representation of all men in the United States. So they have an average age of 70.4 years with a standard deviation of 12.19. From there, I'm now going to do second and distribute, which is the vars button next to the clear key, and when I do second and distribute, that takes me to a list of several distribution functions. NormalCDF, as you see, is the second one in that list. We're going to look at from what is the lower number, which is essentially negative infinity, so we use negative e, which means times 10 to the 99th. And for my upper limit, I'm going to refer to John Adams in this particular example. So John Adams died when he was 90 years old, so I'm going to use that as the upper limit. For my mean, I'm going to use the mean that we get from the numbers that we just used. So I'm just going to set mu equal to x bar, and to find that I did I did vars, and then chose number 5 for statistics, all the variables from statistics, and put in x bar. Now I'm doing exactly the same thing, putting in S of x, which is the standard deviation of that set, and I'm going to hit paste. And so right now what I'm going to do is I'm going to calculate what percentage of people would have died at a younger age than 90, according to this. So 94.57% of all men should die before they reach the age of 90. So John Adams obviously lived a very long life, which, according to this, he lived longer than approximately 95% of all other men. Now I'm going to do exactly the same thing, but I'm going to compare John Adams to his wife, Abigail Adams. So I'm going to do calculate again. This time I'm going to do list 2. So I'm going to do second and L2. I'm going to go down and calculate. I'm going to find the average age for the women. Again, this is assuming that the president's wives are good representatives of the entire country. And so when I do calculate here, I find that the women died at an average age of 70.1 years as opposed to 70.4 years, so a little bit younger than the men. I get a standard deviation there of 16.76. So the spread of the women's ages is a little bit larger than the men's. So I'm going to do second distribute again, and I'm again going to choose NormalCDF. This time, when I go in to look at those numbers, I'm still going to use negative infinity as my lower bound, but now my upper bound, because I'm using Abigail Adams, is going to be only 73, because Abigail Adams was 73 years old when she died. I'm going to leave mu to be equal to x bar, even though I don't need to change any of that. The calculator knows, since I did the one variable stats again, that x bar and sx are new numbers as opposed to what they were a while ago. So when I click paste, this pulls it up to the screen, I hit enter, and I find that Abigail Adams only lived longer than 56.9% of all women in the United States. So John Adams obviously lived a lot longer life than the average male. Abigail Adams' life was not really that much longer than the average woman. So we can compare both of those two numbers using NormalCDF and find the percentage that that number is higher than. I could use exactly the same thing. Instead of using negative infinity up to a higher number, I can use a low number up to positive infinity to figure out what percentage is higher than a specific number. So I could have done the same thing, like if I could put 90 as the low number for John Adams and then to positive infinity, I could find the opposite. Instead of finding out that John Adams lived to be older than 94% of the population of men, I would find that 5% of the population of men lived to be older than John Adams.